So far we saw molecules of atoms bonding together of the same element. Now what could also happen, equally likely, is atoms of different elements combining. So I think we've all seen H2O happen, right? So that can happen as well. These are called compounds. Atoms of different elements that share electrons, these are called covalent compounds. Over here, looking at hydrogen chloride, we can see hydrogen requires 2 electrons in its shell, whereas chlorine requires 8. Each of them want 1 electron. So they end up sharing 1 each to gain 1 each. Over here you can see the electron coming from chlorine is the dot, because every other electron from the chlorine is a dot. And the cross represents the electron coming from hydrogen. And they're being shared over here. Each the hydrogen over here has 2 electrons and is content and happy, whereas chlorine has 8 electrons and is content and happy as well. So now here's another way of how a covalent bond can form. And to show the diagram, the display formula for this, it's just a hydrogen with a chlorine. One single bond between it, because one bond is 1 pair of shared electrons. What if that chlorine is replaced by oxygen? Now oxygen is different from chlorine because it has 6 electrons. So oxygen tries to share 1 electron to gain 1 of hydrogen. So ignoring this, let's say it has 7 right now, right, including its own electron. Hydrogen is content, but oxygen is not content. So it ends up sharing 1 more electron to another hydrogen and forms H2O. This is the molecule for water, H2O. Similarly, carbon has 4 electrons, valence electrons, right? And it wants 4 more. So because each hydrogen is offering for exchange 1 electron, it's offering 1 electron, it can bond up to 4 electrons. So each of these hydrogens are happy with 2 electrons in the shell, and carbon is completely content. By now, it has 8 electrons. By sharing 4, it ended up getting 4 more electrons. So its octet is complete. Here are examples of some more molecules. You have ammonia, very important molecule. You have methanol. Now, not too important, but this is here mostly to show how complicated a molecule can become. They get very complicated if they want to. There's also carbon dioxide, a very common molecule which we study in chemistry. Ammonia is special because notice how it has some electrons that are not bonded. Nitrogen, the central atom, is from group 5 or group 15. So it has 5 valence electrons. So to get 3 more electrons, it needs to share 3, and this is exactly what it's doing. So this diagram may look complicated, but it's very similar to the methane we just saw and the water before it. As long as nitrogen has 8 electrons by sharing 1 and getting 1 in return, as long as the count goes up to 8, it's happy, it's content. Draw a diagram to show the bonding in molecule of methane. So methane is CH4, we've already seen it. But let's figure out how to draw the dot and cross diagram for this. So it's carbon with 4 electrons, because it's in group 4, right? Now, and it's hydrogen, right? So we know there are already 4, but let's try to add 1 hydrogen at a time, and let's see if the octet is being completed or not. So if I add 1 hydrogen, that's what it looks like, right? And I'll draw the electron from hydrogen in blue. So right now, if we take a closer look at carbon, it has 5 electrons in its shell, 4 the pink ones that it originally had, and 1 more from the hydrogen. So we keep sharing electrons until we reach 8, right? So let's make this a little neater circle. I tried to make a neater circle. Now here we have 6, 7. I need a better color. 8. Let me just make this green because I want it to stand out a bit more. Right? And that's what methane looks like. The display formula for methane is going to look like this. A little easier to understand. Each line over here is again a shared pair of electrons. This is what it looks like. Let's try doing for water as well. Taking a closer look at water, it's going to be H2O. So oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. Now normally I draw them together in pairs, but I think we all know where this is going. It'll be easy to draw because each oxygen is shared with 1 hydrogen, and I add 2 hydrogens, and now each hydrogen is happy because it has 2 electrons each, and each oxygen is happy because it has 8 electrons in its outermost shell. To do it for carbon dioxide is you have a carbon atom. Right next to it is oxygen, and even on the other side, I don't like that circle, the other oxygen, right? Now, because it's slightly getting complicated, I'll make a key. The key is representing the electrons that are involved. So the key is carbons, the electron from carbon are X's, and the electrons from oxygen are my dots. So this is called a dot and cross diagram for this reason. So if one carbon shares 1 right now, oxygen shares 1. Same on the other side. So carbon started with 4 electrons, which aren't drawn yet because it'll be in use real soon. But the other 2 electrons it gets by sharing 2 more electrons to the each, and gets 1 in return. Right? And now whatever electrons are left for each atom, we can populate it. So 2 here for this oxygen, or 4 I mean, and 4 here. Now, I think you've picked it up already. A metal and a non-metal will react together to form an ionic bond. Why is that? Because metals are generally, they'll be in group 1 and group 2. They like to lose electrons to form ions. Right? And non-metals like to gain electrons. So whenever you have a non-metal with a metal, for sure it's a ionic compound. That's how you recognize ionic compounds. If it's a metal with a non-metal, if it's a metal with a non-metal, that's a ionic compound, like copper oxide, calcium oxide, magnesium chloride, all metals with non-metals, right? Non-metals react together to form covalent compounds. So if ever you see a covalently bonded compound, for sure it'll be a non-metal, non-metal, non-metal bonded to a non-metal, right? So O2, that's 2 oxygens, HCl, H2O. What else comes to mind? NH3, carbon dioxide. They're all non-metals. There's not really any such thing as a metal-metal bond, right? Okay, the covalent compounds you have met so far exist as molecules. So whatever we've done, we've talked about molecules, and what really is a molecule is different elements bonded together covalently to form a molecule. I think I mixed that up. What really is a compound is it's just a molecule of different elements covalently bonded together, right? And this definition doesn't highlight the confusion. The confusion is when people say O2, they think that's a molecule, and they're correct. So they see, every time they see something like this written down, they think it's a molecule. Well, is H2 a molecule? Yes, it is. We've seen it. Is NaCl a molecule? Wow, wait a minute. Is it really? It's an ionic compound. It's a never-ending repeating lattice of sodium ions and chloride ions. So it doesn't exist as a tiny little particle flying around or speeding around the universe, right? It's a huge lattice. So NaCl isn't really a molecule, even though we write it like this. So when we're talking about molecules, generally we're talking about covalent compounds that make these tiny little structures like H2O and CO2, not like NaCl.